How's it going, everyone? So what I'm going to cover today is I'm going to cover a general electrical issue with most automotive circuits. Now, this is for a check engine light on a 2020 Charger, but this concern can happen on any electrical circuit that is on a vehicle, and it's pretty common on newer vehicles. This vehicle is actually a very low mileage vehicle, and it's something to look for on any circuit, whether or not it's high or low mileage, especially if someone's worked on it. So we have a check engine light on, and we have two codes. So we have P00A3 and P2A0D, which is for the Charger air cooler temp sensor circuit high and manifold absolute pressure sensor circuit high. Now these two codes are actually on the same sensor. So this particular vehicle has a TMAP sensor. So what this is this is a map sensor and temp sensor combined, and there is 4 of these on the supercharger. Now our circuit high is going to indicate that the voltage that it's getting, the 5-volt reference, is completely open. The voltage is, the PCM's not seeing the voltage being consumed. So I've already looked at the vehicle, and what I found is a pretty typical issue on electrical connectors. So if we can actually look, these two center wires, the yellow one with the red tracer and the blue one with the yellow tracer, they have the insulation popped up. What that's an indication of is that's an indication of a pushed out pin. So the fix for this is usually to put these back in when we've removed the lock. The problem is these are going in and they're popping right back out, so the actual connector is damaged. So what we'll need to repair this is we're going to use a connector repair kit, and we're going to be using these special pin tools to unpin the old connector and pin it into the new connector. Now if it was damaged, we would solder in new wires at this point. Okay, so what we get in the connector repair kit is we get a bunch of different sized wires for the different size gauges that this potentially could be for. So this connector is for our TMAP sensor coming off of our supercharger, but that doesn't necessarily mean that this connector isn't used for other applications on the vehicle or on other vehicles. So what they typically do is they send you a bunch of different size gauge wires. So we have some 20 gauge wire and we have some 18 gauge wire. The sensor that we're looking at uses the thinner stuff, so you want to make sure you're matching that up. It also comes with heat shrink, some block off ports in case this 4-pin connector only has 3 pins in it, and then some crimp tees for soldering it. So to actually get these pins out, we're going to slide over this locking tab, and that is going to give us access to the windows to be able to use the special pin removal tool to go into the top and the bottom around the terminal to be able to push it out. Now we can have a situation where the two ends of this terminal, these little tiny pointy ends on top, are damaged as well, and they will not lock in. So we're gonna have to look at each individual pin, and we may end up having to solder new ones of these in. It kind of depends on how it broke, so you do have to take your time and diagnose it. It is usually best to try to save as many of the terminals as you can. That way you're not having a bunch of solder joints all at once. So you know, we'd want to stagger our solder joints as much as possible, but in case, you know, we have to, we want to try to eliminate as many of those as possible, because those are points for shorts in the future. Okay, so what I like to do first and foremost is the factory has real nice connector views. So this is just going off of to make sure I can double check everything as I do it. So it gives me a location for each pin, what gauges is, and its wire color, and also what its functionality is, and what the location is inside the connector. So we want to go one by one, trying to swap each connector. That way we make sure we're getting them in the right order, and we don't potentially cause a new issue with the vehicle. So I have our first pin that's popped out first. What I'm going to try to do is this one is blue with a yellow tracer, and it is in pin number 3. So we're going to try to slide it in and see if it locks. This way I can tell if I have to solder a new end on. So we should hear a click. Okay, it did click, and then I can also give it a light little tug, and it's staying put. So that's good news. So that means I can repin it and go to the next one. and hopefully that's going to be the same boat. So we're doing pin number 2, which is yellow with, it looks like a pink tracer or red tracer. Sometimes they can be a little bit, the colors can be a little bit misleading. That's why it's usually best to have a printout of the connectors. Same thing, we're gonna push that one in. Okay, we're good to go with that one. So then now what we'll do is we'll do the 2 end ones that are locked in. These ones are probably gonna be a little bit more challenging simply because we're gonna have to undo the locks that are already there. And then we can pin the connector in and go from there, getting the circuit completed. Okay, with our last pin in, we can slide over the locking tab, and this connector is good to go. We can connect it back up to our T-map, run through our diagnostics, and make sure that there's no other current issues with the vehicle. Secondary lock. All right, so we'll clear the codes and go check and see if our work is good by looking at the scan tool data. All right, so our first check to see if our system is operating correctly is the status of the code. So our codes went from active to stored. Usually circuit high or circuit low codes are a one-trip failure. They'll set a code immediately. So the fact that they're showing stored indicates that the codes are probably, or the condition is probably fixed. So we're gonna clear all the codes and we'll start the vehicle up and we'll look at vehicle data to be able to see if we have any issues. So we'll run a search real quick for the temp sensors. Okay, so we were looking at charge temp sensor 2. So we're showing 3.71 volts and 22 degrees Celsius. If we look at another temp sensor that we know is good, sensor 1, and that's also reading 22 degrees. The vehicle is cold, it hasn't been driven yet, so the fact that we have multiple temp sensors reading the same is a good indication that our condition is repaired. So what we'll then do is we'll go and start the vehicle. So our check engine light is off. It's normally in this corner right here. And then we can go back to our data and see if we have a change in temperature. All right, so our temperature sensors, again, the car is still cold, so it's not gonna be reading that much of a difference, but we do have normal voltage being showed of 3.75. We could go off of a resistance chart and a voltage consumption chart and see if that falls in line with that temperature reading. But because we have 3 of the 4 sensors reading pretty much the exact same, that indicates to me that this vehicle is fixed. So we'd have to go for a test drive with it and verify that everything's good. We'll double check one more time that there's no DTCs. So it's showing no DTCs present. So this vehicle should be fixed and ready to go. So this concern is a concern that can happen on any type of electrical circuit on a vehicle. So this could be an ABS concern, could be a transmission range sensor concern, could be any other engine sensor concern. So it's one of the things to look out for is pin push out. The repair is relatively easy. As long as you take your time and you pin everything in correctly, it shouldn't be that big of a deal. So appreciate you all watching, and we'll see you in the next one.